minus 3x. Okay, so here's the second curve. Now remember when we from your table again, because we're building up, you had x-intercepts, and remember you find the x-intercepts using synthetic division, finding the zeros. The factor theorem is what you use over there. What were the x-intercepts, Ahad?
0 and 0.
0 and 0.
Negative 3 and 0.
Negative 3 and 0.
1 and 0.
And 1 and 0. Okay, so here we had 3 x-intercepts. What were the y-intercepts?
0 and 0.
I'm going to use, let's say, blue, also 0 and 0. So this one's also quite interesting. Okay, righto. And then, so none of the points repeat, so we're not going to be sitting with a turning point on the x-axis. Okay, now we need to find what? The turning points. Okay, now here's the curve, y equals x cubed plus 2x squared minus 3x. Step number 1 for finding the turning points is you find the, which is what? Dy by dx. Kayla, what's this going to be? Give me the derivative, please.
3x.
Kayla, to the power of 2, because you minus 1 from there. Next one. Positive 4 to the power of 1. And then this, you still have something here. There's a 1 there. And that's it, right? Very good. Okay, what's the next step? Make the derivative equal to 0. Okay, 3x squared plus 4x minus 3. Okay, that's something you want to factorize quickly. Okay, so you do it. Okay, so if I multiply that, I get 9. Factors of 9 are subtracted to give me 4. There's none. So let's use the quadratic formula. So this is solving for x. Step number 3, x equals minus b plus minus the square root of b squared, which is positive 4 squared, minus 4 times 3 times negative 3, all over 2 times 3. Okay. And then we get two results, x equals that or x equals. Okay, so when we work this out, we get 0.54. And the other one is negative 1.87. Okay, so let's take the fraction versions of that and substitute in, and then we get the y coordinates, right? So I'm not going to write out the full substitution. I'm just going to say that must be f of, what is the fractional version of this in your history? The final answer. Okay, so just put f of that. So what do you get when you substitute that in? Into the original equation. And then the other one, f of minus 1.87. Okay. So I'll give you guys a moment to do that. Minus 0.88 and .06. 6.06, right? So once again, these are coordinates. So I'm going to take this back to the previous slide, and these were the steps to finding the turning point. So now I had 0.54, 0.54, yeah? Mama, 0.54 and negative 0.88, right? And the other turning point was negative 1.87 and 6.06, right? Now let's get our coordinate system going. There's my line, axes, as you can see. Okay, let's just take that away there, that little green dot. Okay. Right. So let's plot these points. I'm going to put down my x coordinates, which is at 0 and 0. Right? Minus 3, 1, 2, 3, which is round about there. And then positive 1 and 0, which is about there. Okay, those are my x-intercepts, right? Then I also note that I've got a y-intercept, which occurs over there. Okay, and now I need to plot the turning points. The turning points, which I'm going to put in violet, is at negative, 0, 0,54, this was 1, so it's around about halfway, and negative 0, 0,88, which is about there. So this is my turning points, right? I'll make a violet dot. That's the one. The other one is at negative 1.87. This was, what was this coordinate again? Let me just put it in red. Let's put it down. Remember that 0 and 0. This is at 1. And this is at negative 3. Okay. This one here corresponds, that 0 and 0 is there. This one corresponds to negative. Let's just put that there. 0.54 and negative 0.88. Okay, so now let's get another violet pen. This one is at minus 1.87, which is here close to 2, and it's got positive 6.06. So I'm just going to put it up here. Okay, so that's 3, which is roughly that. That's round about double, which lies about here. Okay. Now there's something you'll notice. Usually your turning points lie in between your intercepts. Okay. And now we just join the shape. Remember, this curve needs to look like that. So now we join it. And again, I'm going to use sky blue. We're going to just go up. We go through there. That's an intercept. So you go straight through. And then you turn around at the turning point. And you go up and through. Okay. That's my curve. Do you see that? Okay. So let's see what this looks like on Desmos. That's x cubed plus 2x squared minus 3x. Y equals x cubed, right, plus 2x squared, what was it? Minus 3x. Do you see that curve there? Do you see 1.87? 6.06? Yes, no? It's actually 6.07. 0 and 0. That's the point of, we will do that later on. And that's negative 3 and 0. So you can see clearly it's that curve. Let's just take this one off. Okay. Does that look like my curve? Yeah, it does, right? Just the scale is slightly different. And those are turning points. Are we good? Okay.